For the next set, we're going to go over odd even identities. Now, the textbook stated, you have also seen that each of the basic trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent, is either odd or even. So that ties into 1.3 about odd and even function. Using the unit circle, you can show that the following statements are true. Sine alpha equal to y, sine negative alpha equal to negative y, cosine alpha equal to x, cosine negative alpha equals to x. Recall from lesson 1.2, 1-2, same as 1.2, that a function f is even if for every x in the domain of f negative x equal, meaning the same as f of x. So the value of f negative x will be the same for f of positive x. And odd if for every x in the domain of f negative x is equal to negative f of x. So what it means is that when you have a negative x within the function, the value that you come out, it will be the negative as if when you plug in a positive for x. These relationships lead to the following odd even identities. So for our odd even identities, sine negative theta is equal to negative sine theta. Cosine negative theta equal to simply cosine theta. Tangent negative theta is equal to negative tangent theta. Cosecant negative theta equal to negative cosecant theta. Secant negative theta is equal to secant theta. Cotangent negative theta is equal to negative cotangent theta. Now, the only ones that are typically the same is cosine and secant, which is, again, we just basically compare to the relationship such as the reciprocal identities and the trigonometric definition from 4.3. So we know that cosine and secant are related to each other, sine and cosecant are related to each other, and tangent and cotangent are related to each other. So again, those, we can use the relationship to memorize this easily. But like I said, memorize sine, cosine, and tangent by heart so that you can tie it to from sine to cosecant, from cosine to secant, and from tangent to cotangent. Now the purpose of this is when you are verifying, proving identities, and if you were given negative angles, you can easily convert it to positive theta, and if it's sine, it would be negative sine. But for cosine, you can also convert it to positive theta, and cosine would be the same. So negative does play a part when proving, verifying identities, especially when you're factoring. There is going to be some factoring which you need to be very aware of, especially when you're memorizing all these identities, such as maybe a quiz that's probably going to come up pretty soon, covering all these identities: reciprocal, quotient, Pythagorean, cofunction, and odd even identities. Just be ready for that.